Hello and welcome to the Daily Space. My name is Dr. Pamela Gay, and most weekdays the CosmoQuest team is here, putting science in your brain. Today, however, is for Rocket Roundup. Like last week, the things we thought would launch didn't. And unlike last week, there was a whole lot of stuff that launched that we didn't expect. The Starliner test flight, for instance, that did not go up. We're hoping it will be coming next week. If it doesn't, there will likely be stories to tell. Let's get to it with those things that did launch, however, shall we? On July 29th at 0401 UTC, a Chinese Long March 2D launched the Tianhua 104 satellite into a sun-synchronous orbit from the Qiaotian Satellite Launch Center. Let's go ahead and watch that launch. From China, we now jump to New Zealand and last week's surprise launch that we learned about while we were recording. On July 29th at 0600 UTC, a Rocket Lab Electron launched the It's Getting Chilly Up Here mission, also called STP-27RM, from Launch Center 1A at their Mohiam Peninsula Spaceport in New Zealand. On board was the Monolith satellite from the United States Space Force. Its mission is to demonstrate the utility of a large sensor on a smaller spacecraft bus, focusing on the possible difficulties in spacecraft attitude control. Specifically, Monolith will carry a space weather instrument package. This was Electron's return to flight after the failure of the previous launch in May 2021, seconds into, second stage flight. Let's watch it, shall we? Rocket Lab recently disclosed that the failure was caused by a faulty igniter from a previously undetectable failure mode within the ignition system that occurs under a unique set of environmental pressures and conditions. The igniter failure caused interference with the signals coming from the launch vehicle flight computer, resulting in the engine gimbal pistons pushing the engine hard to one side and the engine automatically shutting down. After the failure, Rocket Lab began an intense failure analysis program that was able to replicate the failure mode on the ground and implement corrective actions. Rocket Lab's own team worked with the FAA to return to flight with a minimum delay. So why does the FAA, a U.S. governmental agency, care about a New Zealand rocket, and why is Space Force launching from New Zealand? The answer is because Rocket Lab is legally incorporated in the USA with a wholly owned subsidiary in New Zealand, which actually does all the launching bits. Sensitive components such as the rocket engines and flight computer are manufactured in the US at Rocket Lab's facility in Huntington Beach, California, and shipped to New Zealand for integration with the rocket's tankage, which is manufactured in New Zealand. The reason for all the Trans Pacific shenanigans is ITAR and MCTR, International Traffic in Arms Restrictions and Missile Technology Control Regime, the U.S. laws that restrict the sale of military sensitive technology and hardware so that it doesn't end up in the hands of countries or organizations the U.S. doesn't like. Rocket engines and guidance systems fall under this law. In order to launch for the U.S. government, a significant market, Rocket Lab needs to be in compliance with these laws. They apply to any company owned by Americans, even if they launch from outside of the U.S., which is why SpaceX will still need FAA permission for Starship launches from a converted oil rig, even if it is in international waters. This launch was originally planned to go from Rocket Lab's new LC-2 pad in Wallops Island, Virginia. However, it was shipped halfway across the world to Rocket Lab's main pad in New Zealand to avoid further delays in getting the satellite in orbit. Rocket Lab is still waiting for FAA and NASA approval for their autonomous flight termination system for launches from Wallops Island. From New Zealand, we now move to White Sands Missile Range, where at 1820 UTC on July 30th, a Black Bryant 9 launched from the White Sands Missile Range in New Mexico, carrying the Magic's payload in a 307-kilometer apogee. The goal of the MAXIS Marshall Grazing Incidence X-ray Spectrometer payload is to answer some important unanswered questions in heliophysics. Why and how the solar corona is so much hotter than the surface of the sun. One possible explanation is small flares which cause the magnetic field of the sun to tangle and occasionally superheat the corona. A second possibility is constant waves of energy which leave the surface and heat the corona. MAGIX will figure this out by observing in soft X-rays. Other missions have done this, but MAGIX is unique in that it will observe the sun's temperature at a much higher resolution and thus be able to tell the difference in temperature between different parts of the sun's active regions, doing this in higher detail than ever before. Besides heliophysics, gaining a better understanding of coronal heating will benefit society at large because of improved solar flare and coronal mass ejection predictions, which can and have destroyed entire electrical grids and even satellites in orbit before. Those coronal mass ejections, they can get nasty. After its observations, the payload was recovered via parachute on the ground. And after a break, we will be back with more launches, this time by Arianespace. Hello and welcome back. On July 30th at 2100 UTC, an Ariane 5 ECA rocket launched the Star 1 and Eutelsat quantum satellites into geostationary transfer orbit. The rocket took off and almost immediately disappeared into a low cloud bank, reappearing a few seconds later. But the webcast switched to an animation and stayed on the animation for the rest of the flight. More rockets, please, Arianespace. More rockets. This was its first launch in almost a year after it was grounded following payload fairing issues. These issues are particularly important to solve because an upcoming Ariane 5 flight will carry the long-delayed gilded infrared space telescope, which shall not be named, towards its final position at L2 out past the moon. The ULA Atlas V 500 series rockets also halted all but one launch because they use a similar fairing made by the same manufacturer. Let's watch the launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Équipage AP, décollage. Remettre à bord nominaux.
The launch was successful, and the two payloads were successfully deployed at the proper times. Star 1 is a fairly conventional communication satellite with lots of transponders in different bands and will be used to provide direct to home television, broadband internet, and other services in Brazil and neighboring countries in South America. And from a massive rocket, we now move to a tiny rocket that tried. On August 3rd at 0743 UTC, an Ispace Hyperbola 1 rocket launched from the Jiaoshan Satellite Launch Center in China. However, it failed to achieve the proper orbit. This was the third flight of a Hyperbola 1 rocket and the second consecutive fail. For whatever reason, it was called Y5 or Vehicle 5. Ispace is a private sector Chinese company but receives significant support from the Chinese government through its state aerospace company, China Aerospace Science and Technology Corp., in the form of solid motors from military missions, which Ispace uses to make its orbital rockets. Hyperbola 1 can, in theory, put 300 kilograms into orbit, but Ispace has plans to make rockets with motors built by the company. Hyperbola 2 will be a much larger methane and oxygen-fueled vehicle that will be capable of putting about 2 metric tons into low orbit. Much like SpaceX's Falcon 9, Hyperbola 2 will land its first stage for reuse rather than letting them fall into the ocean. Future variants of that rocket will see additional first stages added as boosters, similar to the Falcon Heavy. Based on comments from users on the Chinese spaceflight forum, naively, it appears that Hyperbola 1's fourth stage did not achieve the proper orbit and the payload fairings were apparently still attached, meaning the satellite could not separate from the rocket. This is consistent with reports by China's state media, Xinhua, which stated that the performance was abnormal and the satellite did not enter orbit as scheduled. The United States Space Force 18th Space Control Squadron, the unit that does surveillance of objects in orbit, did not track any objects in orbit associated with the launch. So whatever orbit it managed was short-lived. The satellite payload was likely the first Jilin-01A Mofiang Magic Cube, the fourth generation of the Jilin-type optic remote sensing satellites. It is significantly lighter than the first generation of Jilin-1 satellites, weighing just 18 kilograms compared to 420 kilograms, while managing to provide a ground resolution of 1 meter. No launch video was provided. The best we could find was a very low-quality photo of the rocket's plume after liftoff. Instead, here's an illustration next to a plume. After the break, we will be back to discuss Vostok 3 and 4 and this week in space history. This week in rocket history, the first time 2 crewed spacecraft were in orbit at the same time, Vostok 3 and 4. The goal of the mission was to further expand the capabilities of the Soviet space program, which had recently sent the first human to space and set in-space duration records. Their uncrewed spacecraft were setting records too, including lunar flybys and the first attempt to send something to both Venus and Mars. The next challenge was controlling 2 spacecraft in orbit at the same time. In 1962, Vostok 3 and 4 were launched 1 day apart. Vostok 3, carrying Adrian Nikolaev, launched on his Vostok K rocket on August 12th at 0802 UTC. His spacecraft was codenamed Shkol, which means Falcon in Russian. This mission was pretty simple: attempt to function in weightless conditions and test the spacecraft systems. This was humanity's fifth orbital spaceflight after all. He also took color films of the Earth below and the inside of the spacecraft. A secondary goal was to communicate with the Vostok 4 spacecraft, which would be launched a day after his own. He was intended to spend 3 days in space. Vostok 4 with Pavel Popovich did indeed launch the next day on August 13th, 1962, at 0802 UTC. The spacecraft was named Berkut, which means Golden Eagle. Nikolaev and Popovich were able to make direct radio contact when they came within 5 kilometers of each other immediately after Popovich's launch. Because this wasn't a proper rendezvous, merely well-timed launch, the two spacecraft drifted out of communications range rather quickly. Nikolaev reported sighting the Vostok 4 spacecraft during the close approach. One of the things that intrigued our writing team about this group flight was the careful discussion between the different groups in mission control on what to do with Vostok 4. Popovich was having problems with his spacecraft's life support system about a day after entering orbit. The cabin temperature had dropped from a borderline comfortable 27 degrees Celsius at liftoff to a chilly 13 degrees Celsius after the 29th orbit on the next day, August 13th. On August 14th, the temperature further dropped to 11 Celsius and the humidity to 35%. Ground control discussed whether to bring him back early or even extend it another day. There were many factors to weigh in the decision, including detailed medical examinations planned for after the flight, concerns about his condition after 4 days in space, and pre-planned events at the Kremlin with Premier Khrushchev and the pilot of Vostok 3, Nikolaev. Ground control first asked Popovich if he was okay with extending the mission by a day despite the life support system issues, to which he enthusiastically replied yes. They eventually decided to bring back both Popovich and Nikolaev on the same day, in part because Popovich had used life support consumables at a higher rate than Nikolaev had, because Vostok 4 was originally only expected to spend 3 days in orbit, and Nikolaev was expecting a longer mission and conserved his. But the factor that was probably given the most weight in the decision to return early was caused by Popovich in Vostok 4 having inadvertently used a code phrase that indicated he wanted to be returned to Earth immediately because of a medical problem, specifically space sickness. The phrase was, "I see thunderstorms." The Russian word for thunderstorms is gruza. In fact, he had actually seen real thunderstorms, but ground control interpreted that as the code phrase even after he clarified his use of the phrase. Later reports suggest that it was believed that he had experienced a bout of nausea, panicked, and sent the code message, and then subsequently covered it up when asked about it by higher-ups in the cosmonaut program because he was embarrassed. One final factor was a 40-minute deadline from the apparent emergency call to set up re-entry so that the two capsules would land near each other at the nominal landing site in Kazakhstan. If they had extended the flight, he would have landed at a reserve landing site, which was mountainous. This would have made recovery difficult and compounded his worse condition after 4 days in space. However, the die had been cast, so to speak, and Vostok 3 and 4 were returned to Earth earlier than originally planned, landing within minutes of each other on August 15th, 1962, after almost 4 and 3 days in space, respectively. The flight cleared the way for additional group flights. Vostok 5 and 6, and even later Soyuz group flights like Soyuz 2 and 3, and Soyuz 4 and 5, and Soyuz 6, 7, and 8. In a post-flight debriefing, Popovich cleared up the confusion, and his superiors realized he would have been good to go for the full 4-day mission. The thunderstorm's call was truly a misinterpretation. After a break, we will be back with Nothing You Can Misinterpret as we present you this year's stats about launch missions. Stay tuned. To wrap things up, here's a running tally of a few spaceflight statistics for the current year. Toilets currently in space, 8. 4 installed on the International Space Station, 1 on the Crew Dragon, 1 on the Soyuz, 1 on the Shenzhou, and 1 on the Tianhe. Total 2021 orbital launch attempts, 73, including 4 failures. Total satellites from launches, 1,309. We keep track of orbital launches by where they launched from, also known as spaceport. And yes, this does sort of look like the medals tally you are probably seeing on Olympic reporting right now. That was actually our inspiration. Now you know. Anyways, this year so far, USA 27 launches, China 26, Kazakhstan 6, Russia 6, New Zealand 4, French Guiana 2, India 1, Iran 1. Your random space fact is that one of the Soviet space dogs, named Bobek, ran away before his flight in 1951. A random stray was collected from the barracks and named Zib, a Russian acronym meaning substitute for missing Bobek. Zib launched into space on an R-1 rocket on September 15, 1951, and was successfully recovered. This has been your Daily Space.